learners. Welcome to Education Online program. I am teacher Willa Lucia. So, in our previous lesson, we looked at the equations of motion, how we can use them in calculating some other questions. So today we shall be looking at a graphical representation of linear motion. Because when you look at linear motion, it's not that it cannot be, because any other motion can be described also in a graphical way. We cannot only put them in a written in words, but then we are going to see how that is done. So basically we shall be looking at graphical representation of linear motion. So it can be your own journey. How do you plan for your journey? You can plan it and you just put it in written form, or you can plan it in a graphical way. For example, you're moving from home to school and you want to represent it in the graph. How would it look like is what we shall be seeing. So you'll find out that this graphs here it has got two types. So we have the distance time graph, and then we have the velocity time graph. So these are the two types of graph. The first one is our distance time graph. And then we have the velocity time graph. So for today we shall start with one, because we shall look at both but one at a time. We shall start with the distance time graph. So this distance time graph here represents the distance you're going to cover, the distance from one point to another, and then the time interval you're going to take to go from one point to the other point. Then you'll see that this distance time graph has so many things, because there is a point where you just start the journey from a rest, or from the zero position, where you say that the velocity there is zero. Then you accelerate constantly. You reach a point, sometimes you try to say, let me rest. Then what happens during that rest? You see that there is no velocity, the body is not moving. So you also, after reaching your point, you still come back. You come back home from where you started. So we're going to see how we shall represent that. So with this, we have the uniform velocity. Those are the common things the common parts in the graph. We have the non-uniform velocity. We have when the body is at rest, and then we have when the body is returning back. So reversing the journey. So we are going to take this. Let's look at the example of yourself. You're from home. You have to go to school. So you have moved from home to school. When you reach school, what happens? You sit in the classroom, because that is where you're supposed to be, in the school, in your classroom. So when you're sitting in the classroom, what happens? So you'll find out that you don't just sit in the classroom from morning up to evening, but there are some things you do in the middle. You can move from the class and go to the urinals. You come back to the class, or you can move from the class and go for break, and there is lunch there is this. Then after finishing everything in school, what happens? You're going to move again from school then back home. Let's see how we shall represent that on a graph. So you see that in a graph, you have two axes. You have the y-axis, and then you have the x-axis, which is known as, the whole of that is the Cartesian plane. So let's see this. We can have here, this is what is known as the y-axis, which is the vertical line, and then we have this horizontal line here. Is what is known as the x-axis. So with distance time graph, what happens is that on this vertical line here, this y-axis, you're going to be demarcating all the distances to be covered on this y-axis. So this y here represents the distance to be covered, and then on the x-axis, the x-axis will represent the time. So at what distance, okay, what time do you take to reach a certain distance? So with a distance time graph, then this one here, we shall have our distance, which we normally write as s. The displacement is still the same, and this one is measured in what? It is measured in meters. Make sure whenever you're putting the unit, all the things on the x-axis or y, you should also include the unit of that measurement. So on the x-axis, we say that we put the time. So we know that our time has, we abbreviate it as t, and then the SI unit of time, we need to include it there, which is it is measured in seconds. Okay, so that is how our distance time graph is going to look like. So you find out that when you're plotting this, there is where the body moves with a uniform velocity. We have where the body reaches a point, it doesn't have uniform velocity, then that is when it is having non-uniform velocity. And we have a situation where the body is at rest, it is not moving. So there is also a point where the body has to return back to its normal position, or to its previous position. So let's take a look at when the body is moving with a uniform velocity. How do you represent that on your graph? So you'll see we have uniform velocity. So if the body is moving with the uniform velocity, we should first have our y-axis and the x-axis. Let's see it there. So this one will take the time right here. This is our time measured in seconds. Then we have on this axis here, we have our distance measured in meters. So when you're moving with a uniform velocity, that is your movement from home to school. So if you're moving with a uniform velocity, what happens there? That means that the acceleration there is 0 or constant. So you're moving from here. Now saying that you're moving, your school is right there. This uniform velocity means you're moving from here to your school. So you're attaining a uniform velocity. What of when you are in the school, when you reach the school and in your classroom? What is that? When you're in the classroom, that means that you're at rest. The moment you sit behind your desk and listening to the teacher, you're not moving. There you're at rest. Then when you're at rest, how does it look like, the distance time graph? So at rest, when the body is at rest, this is how you represent it on the graph. You first draw again your y-axis, and then you have the x here. So you have your time on the x-axis in seconds, and then you have your the distance in meters. When you're at rest, there is no distance you're covering. That means you're not moving from that point. You're just seated behind your desk. So meaning that there is a time you take. You start from this point here, and when you're moving, you start plotting from the y-axis, moving, covering some distance, because when you're sitting there, it doesn't mean that there is no time taken. As you're sitting, there is time also elapsing at that point. So when you're at rest behind your desk, this is how it looks like. There is no distance you're covering. So what if you're now in the classroom and you have to move for lunch? You have to go for break. How does it look like? Let's look at this. So when it is, that means that you're moving with a non-uniform velocity. So when it is non-uniform velocity, we take it as the time from the class to the toilet, or for break, or for lunch. So this one becomes our non-uniform velocity here. So how do we represent it there? So it moves this way. You're not moving with a constant velocity. So this is representing the time you're going to be moving out of your class, but within the school premises. So if it is like that, what of the time you're supposed to go back home? How do you represent it on a graph? So you'll have it there as your this one becomes when you're at a uniform deceleration. So here we shall have also our y-axis and then the x right here, where here we have our time in seconds, and then we have our the distance covered in meters. So this time we have covered you. Here you're going to the school from home. Here you are you're resting in the classroom. You're seated behind your desk. So here you reached a point where you're moving out from the class around the school premises. Then what of going back home? How would it look like? So that is what is called as so when you're going back home, it appears like this, a steep slope going downwards, like that. So you'll see that here you've represented your whole movement for the day in a graphical way. So at the last one, you can either say uniform deceleration, or you can say that when the body is returning back from the journey, it is all the same. So you'll find out that this whole, instead of having so many graphs, just like what I have done, you can combine these graphs and to one single graph. So how do you combine all this in one graph? Let's look at this. So we want to combine combination of the graph. So instead of you having so many like that, let us try to combine them into a single, and we see how it will look like. So since we say that, let's first have our y and x axis there. then we have this time round, instead of us dividing the journey that way, let's try to combine it in one single graph. So here we shall have our distance moved in meters, and here we have our time in seconds. So we say it with a uniform velocity. You're moving from home to school. So here, at the time you're moving from home to school, you're accelerating with a uniform velocity like that. So when you reach school, you sit behind your desk listening to the teacher. Here you're at rest, moving like that. So it will reach a time where you need to go back home. You're returning from your journey. So we shall have it here. Let us extend this a bit, make it longer. Okay. This is our time. So we are now moving from school back home. So we are having it from here, right here. We shall have this going backwards like that. So you see that instead of us having so many graphs, we have decided to combine the three. When you're moving from home to school, then when you're in the classroom attending your lesson, and then when you're going back home. Here we don't have the non-uniform velocity, the moment where you're in the school premises just moving up and down. You see that when you have your graph like that, and then you have figures, it is very possible for you now to describe your motion to someone. Let us see how you can describe. If you have something like this, let us have some other graph here. We have this, then we have this. We're trying to find this graph so that we see how we can explain our graph. So we have our demarcations here. The body, we have, let's take from 100. We expect this body here, the distance covered up to this point is 100. So here is 200. So we have 300 somewhere here. But then this side here is our distance. We should not always forget that, and it is in meters. So here, we're having our time. The body will be covering. So let's see that. If we have here as our 8, and then we have 24, then we have 32. On this axis, what are we doing? We are plotting our time this way. So this is for time in seconds. So let us see. We are moving from this point. Let us make it as our 0 point. So you're moving now to a distance somewhere up here. So we have our graph like this. Then we move here. We have this when the body is at rest. Then we move from here. Okay. We can have it here. Let's change the position of this 24. Let's have it somewhere here, next to this corner. when we take it downwards, somewhere here is our 24. So if you have a graphical representation of your journey like that, how would you describe the motion of the body? So for you to describe this motion of the body, that means that you need to know at what rate was the body accelerating. Because if you look at the distance time graph, the steep, which commonly is known as the slope, gives us what? The speed. The speed you're using, the speed the body is using to move from one point to the other. That is when you're finding the slope. So how would you explain that? So to explain that, that means that we need to know the acceleration of this body, because this body is going to move from point A up to from point O here to maybe point A, then to point B. These are different locations. Then we have another one here, which is the point C. If we want to describe that, we need to know the timing, the time interval. What time has the body taken to accelerate or to move with the uniform velocity? How long was the body at rest? And how long did the body take to return back to return back from the journey? All that we need to know. So you'll see that to know the time interval that the body was moving with the uniform velocity, just come and see from the 0 point here, the body is moving up to A. So at this point here, that means the body is moving with a uniform velocity. So the time here, you're going to check when you cross that from this point, try to connect it to the time axis there. What happens is that this one here, we are moving like this. So you try to bring it down where this axis is that the time has been plotted on. So because all this is representing the time, that means that our body started at rest and then it moved with a uniform velocity for how many seconds? Check. This is our timing here. And this is where the body stopped moving with a uniform velocity. So from OA, the body is moving with a uniform velocity for 8 seconds. Because if you come downwards up to pulling from where the body ends, that is A, then you come down on this axis, you'll see that it is on 8. So at what you look at the rest, how long did the body take to rest? That is our A, B. So for you to look at that, remember this 8 seconds here, the body has taken this 8 seconds here to move with a uniform velocity. So if it has moved with that, we need to eliminate this so that we get the time interval when the body is at rest. That is from this point here up to down. So you see that the body stops resting when it reaches this B here. So when you come down, you find this is 24. To find this time interval between here, you just get your 24, subtract 8 from it. What will you get? You can just do it like this. You have 24 minus 8. So what is it? You get this one and add it there, making it 14. Minus that, you will get 6. 14 minus 8. Then here you are left with 1. So this is your 1. So meaning that the body rested for 16 seconds. So for all the 16 seconds, the body did not make any kind of movement. So after the 16 seconds, what happened? The body started going back to returning back from the journey. That is our line there, B, C. What time did it take for the body to return here? So you'll see that for this case here, you don't need this timing here, because from this point here up to here, the body was resting, and from here, from this timing up to this line here, the body was moving with a uniform velocity. So it is returning here. So you're going to take where this number here, which is the 32, and then you subtract this 24 from it. What will you get? If you borrow 1, you'll have 12 minus 4, you'll get your 8. So here you are left with 2. 2 minus 2 is 0. So the body took 8 seconds to come back to rest. So if you're trying to describe this motion, we can say that the body started from rest and moved. It moved with a uniform velocity for 8 seconds, because here up to there is 8 seconds. Then it rested. It rested for how long? You get 24 minus 8 for 16 seconds and returned back from the journey. This one is for how many? When you get 32 minus 24, it is 8 seconds. You'll see that your whole journey, you just described it in a very short, in not so many words. So this is how you can use your time graph to represent your whole journey. You find out that it's much easier than writing everything down. So the other thing you have to know about this distance time graph is that from point O to A, the body is moving with a uniform velocity. That means that this line here has you get a positive. This is because it is moving. Then it is moving from O upwards. Then look at this B. The B is coming from B to C. It is moving the opposite direction from opposite of this. That means that this journey here, we shall have it as a negative, because there the bodies are retarding. So when it is moving, when you're moving from home to school, it takes a positive. But when you're coming back from school to home, it carries a negative, because you're moving just the opposite way from what you first did. So this is more of our time graph. But then we have just seen the distance time graph. We still have the velocity time graph. So we shall look at velocity time graph in our next lesson. So thank you very much for attending the lesson with me. We keep on attending every time.